This is Axiom, a 2D top-down sandbox game I built in Kotlin using LibGDX, a game development framework. It's got procedural world generation, an event-driven architecture, 4 enemy types with their own state machine AIs, and a full authentication system with a global leaderboard. Let me show you how it works. So you control your character with familiar keys, WASD, and you can left-click to attack. The world itself generates infinitely using Simplex noise. So we have water, sand, grass, and mountains, which are all determined by the elevation and the moisture values. Enemies spawn around you whilst you're moving around. Slimes are the most common, and there's demons, which are quite rare, but they have the most health and hit way harder. The architecture is built around loose coupling. So on the game side, I've implemented an event bus using the observer pattern, which means that when something happens, like an attack or a player death, it emits an event that any system can subscribe to. This means that my combat system doesn't need to know about my score system. They just communicate through events. Enemies use a state pattern for AI, so their states are idle, wandering, chasing, or attacking, with clean transitions. Entity creation goes through a factory pattern for consistency. For player data, so authentication, profiles, leaderboards, I decoupled that entirely into a separate SvelteKit REST API. That's a JavaScript framework, backed by MongoDB. The game client just calls methods like login or submit score through an API client class. It doesn't know or care about HTTP requests, cookies, or database schemas. That separation means I could swap the backend entirely without touching the game code. I think it would be useful to walk through each key feature. So let's start at the entry point, the login screen. Your credentials are sent to the SvelteKit backend, handled by our authentication library, BetterAuth, which returns the session I then store via cookies. You can also switch to the register screen, which does the same thing, but obviously for creating an account rather than signing into one. Once you're in, it's pretty simple. You can start a game, view the leaderboard, or sign out. The leaderboard is fetched asynchronously, querying that SvelteKit REST API again, giving us the ordered top global scores. Playing the game itself, the world generates around you, new chunks load as you explore, and enemies spawn frequently to target you when you're in range. For combat, it's left click to attack, you do damage in your radius, and enemies have varying health, which is visible through their little health bars, and they have different stats per enemy type. Finally, dying. You lost. The game over screen shows your kills and survival time, and your score auto submits to the leaderboard, posting to our REST API. My favorite part of making this whole game was probably the world system. I think it has to be the most complex bit. We're using a strategy pattern, so world generator is an interface, and then we have a noise world generator, which is one implementation using Simplex noise. Generation works in layers, so first I sample elevation noise to get a value between 0 and 1, and then moisture noise. Those two values together determine the tile type. So low elevation is water, mid with low moisture is sand, mid with high moisture is grass, and high elevation is mountain. The world's split into 16 by 16 tile chunks. If you're familiar with games like Minecraft, that's kind of the same system. Only chunks within a radius of the player are kept loaded as to not eat up too much memory. As you move, the game calculates which chunks should exist, generates any missing ones, and unloads the distant ones. Each tile also has properties like whether it's solid for collision or a speed modifier. Water is solid, which may seem counterintuitive, but is to prevent you from going in it. Then sand has a negative speed modifier, so that you move slower over it. Each chunk load and unload fires through our event bus, so any system can react to world changes just by listening to it. In summary, that's Axiom. Procedural generation, event-driven architecture, state-based AI, and a decoupled REST backend. WASD to move, click to attack, survive as long as you can. Check it out at axiom.joshbaker.gg. Link in the description.